Keep on hitting the wrong buttons. There we go, we're back. Our goal for today is to make it so that when you read a word problem in this section, we're going to cover every single word problem out there. It's actually kind of a college class for that, and it's not very fun. My textbook was literally a little baby book that was really thick and just had word problems. That was it. Yeah, it was called Math Models. That kind of makes sense with the section, right? Mathematical modeling. Anyway, it was a struggle, so I hadn't taken all my math classes yet. That's okay. The nice thing is, what I'm going to cover in class today is preparing you exactly for the types of word problems you will see in homework. So we're covering very specific vocabulary, translating it in a very specific way to lead to very particular models. So for right now, on this page, go ahead and write every word you see. This is to prepare you for seeing a bigger or a longer or a more involved word problem. To be able to quickly write down the important information without losing anything. To be able to quickly write down the information without losing it. Josh, are you back yet? I know it's cold, sorry. It was warm all morning and then it just turned on before you guys got in. A bit of a struggle. Alright, kiddos, quick reminder, we're in section 1.10. This is the final section before the test. The test has been moved till Monday. It's on the backboard if you need reference. 110 should be due tomorrow, and if we can, I would love to get in homework today, but we have to work quickly and efficiently. I'm going to grab out a highlighter to help us just a little bit. But as I do, kind of random question. It's not totally random. And to be honest, I'm actually going to erase these. This is the wording that we need to be looking out for, but this is basically the model that we need to be able to plug into. Direct variation varies directly proportional to. All of these are synonymous. All of these point to this relationship. However, I want you guys to notice that whatever quantity comes before is going to be our y. But remember, y's don't always have to be y's. They can be b's or s's or p's or a's or who knows what else. Okay? So whatever quantity comes before is going to be y. It's going to go in this spot. Whatever quantity comes before these relationships, because it's going to be the dependent quantity, because it's the one that's being affected by this one over here that's going to be the independent or the x. So remember, even though you've seen y's and x's, this is probably the second time this year that I really made a big deal about it. And the other time was a function of and dependent, independent variables. Doesn't have to be y, doesn't have to be x. You have to be able to look at the wording and say, okay, whatever comes before is going to be what's equal to in the equation. And whatever comes after is going to be after the equals and multiplied by the constant. Whatever that quantity is, whatever that variable is. I just want to real quickly intro this. Does anybody know anyone who's a court reporter? Super random. You guys know what a court reporter is? Remember I was at jury duty that one day? Okay. Court reporter, you have the courtroom, right? You have the judge right there. You have like the court, what's it called? The court clerk? That's the one who comes out and gets the jurors and does all the like behind the scenes and answers the phone calls, all that. You have the security officer, it's not called that though. Bailiff, yeah, you're right. Bailiff. He's over there. He was just chilling. He was just blazing out over there. But anyway, he was there just in case something happened. So you have the police officer right there, you have the bailiff, or the security officer, whatever it's called. Then you have the court reporter who's like down here, and then you have like the jurors who are over here, and then you have like the defense over here, the prosecution over here, and then the plaintiffs and all that sort of stuff. Okay. So the court reporter, what's their job? Does anybody know?
To write down everything that happens.
They literally have every single word that is said that is on the record in that trial. Why would that be a hard job?
Yes, people talk fast.
It's a lot of pressure because if something happens, they come back to what you wrote, right? As to what was actually said, et cetera, et cetera, et cetera. But then you also have to go super fast and not miss anything. True?
Yeah.
Okay, what did I say about word problems? Our goal. To be able to do it quickly, because you don't like taking forever on a word problem. To read it, pull out the important information quickly, and not miss anything, right? In the olden days, before, it was actually kind of funny, the judge went back with the defense and the prosecution, and we're like, we're going in the back on the record, so then the poor little court reporter had to pull up her little, like, typewriter-y thing, and it got stuck, and then she had to, like, go back there with her little typewriter-y thing. It was actually pretty funny. It had, like, a little stand, but it was small. It's not like a whole big old typewriter. In the olden days, typewriters were like boom boom, right? Secretaries couldn't just like whoosh, and like go into the office where their boss is and then start typing. So they used to have, and my mom took this course when she was in like secretarial business school. It was called shorthand. Has anybody ever heard of shorthand? Okay. Shorthand is a way of writing everything someone dictates. So it would have been before the dictaphones, before the tape recorders, before whatever people can use now. Okay. What's a secretary's job if she's supposed to type up a letter for her boss? To get every word that he says, right? But if he's just like, I want to write a letter to this person, I'm going to say this, okay, here's so-and-so, If you watch some old movies, sometimes you can see this happening between like a boss and a secretary. And she has to get every word down. How hard is it to write every word if someone's just talking normal speed?
It seems very difficult.
It's very difficult. You're not even typing, and we can take typing classes. You know, some people can't like crazy high words per minute, and some of you have done that in like computer classes, right? Okay, you're not typing, you're writing every word. So they developed this whole idea of shorthand, where like different words and different characters and different commonly used this, that's, and the others. The secretary's not literally writing down every letter, every word. She's using the shorthand, which is kind of like a whole new language, where she can know what's going on and she can say, hey, I got it all, but she didn't have to write every letter, every word. In homework, when you get to doing a word problem, do you want to write every single word?
No.
No. Now, do you probably need to read every single word? Yes. But what you want to write down, because you guys are trying to simplify and make homework shorter, right? You want to write down just the important stuff. So you need to learn the shorthand for word problems where you can shorten what's there, make it more concise, but then also, once again, not miss anything. Now, court reporters, to be honest, I was hoping one of you knew someone who was. I don't honestly know what they do. Maybe they literally, because they're so fast, they literally type every single thing. Or maybe they use like a shorthand where certain combinations of letters or characters, etc., stand for different things. I don't know. I'm curious. Maybe we should look it up, but not right this second. The idea is you don't want to have to write every single letter, every single word, so how do we shorten it? Pause. Is there anywhere else in life, or even in high school, where it might be useful to look at a lot of information to condense to what's important while not missing anything and then be able to use that smaller piece of information?
Literature.
What? Literature, yeah, definitely. You have to read these big works and pull out the important ideas and then be able to apply. How about the SAT, reading comprehension?
Yeah.
Ooh, anybody ever not been able to finish reading those passages on the ACT or the SAT, right? Okay, what do you have to do? Read quickly, true, but you have to be able, your brain has to be able to pull out what's most important here and then be able to do something with it, right? Maybe the same thing in some of the other, does any other class have any sort of wordy passages or wordy problems? Almost everything. History you have to read, right? Chemistry and biology, usually there's a lot that you have to process on your own. Not that we don't have excellent teachers in those subjects, but I'm just saying there's usually a lot of information, and you guys, we can only process so much. So we want to condense it, we want to make it simpler. Now, these are pretty basic. There's not many words. There are not many words. But I can say, and you hopefully after this page, and all these different ideas or all these different types of problems will hopefully get to the point where you can read a problem, this type of word problem, and say, hey, I can simplify, or I can shorten, or I can model what they're giving me with math and use that, and not necessarily need to write all the words. So as you're reading through this one, simple interest is directly proportional to the amount of the investment. Okay, statement, you read all the words, now what? We need to set some variables. If we're going to write this in the short and sweet version, we need to make some variables, right? So what can we call simple interest? We could call it S. Can I just kind of help you out with, like, normally in finance is what it is? Simple interest we almost always call I. Okay? You've written the word, so in this one, go ahead and label it I. Could you name it Y? Yeah, you could. You could name it Y. But to some extent, there are so many different variables in so many different fields, we can't just use Y's and X's all the time. So interest is almost always I. Is directly proportional to, we'll come back to that in a second, but the amount of the investment. I know some of you are like A, some of you are like I. Can anybody remember the special letter that stands for the beginning amount or balance of an account?
P.
P, principal. Almost always. Some of you have seen, or well, all of you should have seen. Interest equals PRT, I equals PERT, or P times E to RT. Anyway, don't worry. Sometime last year, I'm sure you did a finance problem. Don't stress if you don't remember. P, principal, almost always stands for the beginning balance of an account, what you put into an account, or what you put into an investment. Okay, so theoretically, you could, in like your homework, say simple interest, or just say an interest problem, and then go ahead and do, well, how do we shorten all this wording? How do we get all the important information, not missing anything? Using this one little model, what can we say?
I equals KP.
I equals KP. So technically in homework, you can almost say interest colon I equals KP. It's the interest problem, and what did the wording say? Interest is directly proportional to the principal. You got all the information in this one little model. Does that make sense?
Yes.
It's pretty nice if we can get all of that into this. And this is an equation that if they gave me stuff like, hey, so if you invest this much and if you invest this much, the principal, and you got this much interest out, and they're probably not going to give you time and all that because they're not giving us all the extra. If they could ask for what K is, you could solve for it, and maybe you can even use this model to do something. How about the next example? You guys wrote all the letters, all the words. What did they already tell us to use as the variables? Distance is S. Modulo falls varies directly as, there's our hinge, we need that. As the square of the duration T of the fall. Now, if you were shortcutting it too much, can anybody tell what common mistake someone would make, what equation, what model they would write if they read it too fast? S equals KT. Hopefully they know directly proportional is K times. If they did S equals KT, they're almost right, but they left an important piece out. You have to use the words as well. What does it say about T? So, the proper model is S equals KT squared. Do you have all of the information in that one little model? Yes, and how would you put some words to it? I don't know, talking about distance, right? You probably know T is time. But you could say distance S times T, and then say S is equal to KT squared. I would read that as, oh, so you mean the distance is directly proportional to the square of the time? And you're like, yeah, exactly. A lot faster, right? Okay, so that's how to make models whenever we see the wording directly proportional to, varies directly, or direct variation. Does that make sense? We just have 3 more and then we're done. You ready? Inverse. Inverse variation. As you guys write, hopefully you know what model I'm going to highlight. I'm going to go ahead and put my little green boxes around the Y's just because, once again, we don't have to call them Y's. This has to be a quantity. So all we're doing is learning mathematically what these relationships mean and how to model them with equations. And after we learn how to translate, we're just going to use them a couple times and then be done. So, inverse variation. It's good in notes to get down the word for word if you can. But soon it's going to get to be too many words, so we're going to have to just read what we have and carefully write down the short and sweet version that doesn't leave out any of the important information. And similar to shorthand for secretaries back before computers and dictaphones and all that sort of stuff. Similar to court reporters in the courtroom. We're just using it to make our homework go a little bit faster. I have no idea. But it would be a super interesting job, right? You would hear all the different cases. So that's why I'm thinking it's not every single word. I'm curious. It has to be some sort of shorthand, I would think. Does anybody have someone who works in like a courthouse or a court? So you can always ask them, hey, talk to the court reporter, what's going on? You can Google it. I'm sure we can figure it out. One of those new verbs is on there on the last one. Okay. Demand for a product varies inversely as the price of the product. It's up to you guys. Technically, if we were writing this, we probably would need to say something about what we're doing with demand, right? So demand, what do you want to make it? D? D. Yeah, that makes sense. D for demand. And maybe this is how you start writing the problem. You're like, okay, demand is D. Price, probably we're just going to call it, yeah, probably just D. Our relationship is varies inversely as. So guys, how would you model it? Yeah. Yeah, super important idea for economics. As the product gets more expensive, the demand goes down. Varies inversely. As one goes up, the other goes down. Now, it doesn't mean that the desire goes down. The price goes up, maybe the desire goes up. Then it's more valuable, but the demand goes down. Fewer people will buy it. If you're interested in business, there's a lot of crazy stuff going on in econ. How about combine? Ooh, there's a lot more words in this one. Okay, maybe don't write all the words in it. Maybe don't write all the words in it. Maybe instead of writing all the words, maybe just tell me the variables you're going to choose for each of the quantities. That's faster, right? So go ahead and write down the important. Sorry, it's combined. I don't know why it's on the screen. You guys wonder? The projector can only be adjusted so much before that whole setup right there needs to be actually moved, and you can imagine how big of a job that is. So I got a new projector last year. The screen works differently than the old projector, so the current setup is not ideal for my smartboard. I can move it and I can shift it, but there's still always that's why it's not quite perfect right now, because that setup would be very hard for our guys to move. It was fun. Combined. Some sort of combination of direct and inverse. What I want you guys to do, instead of writing that whole paragraph, is to basically identify the players. Identify the key quantities in this problem. So what have you guys identified so far? Okay, so resistance is a good one. So resistance, you could have written that down and then probably called it, and that covers all of that, right? R is going to be the resistance of a copper wire. Wait, isn't it way more than that? Yeah. It's like the whole thing. R stands for the resistance of a copper wire carrying an electrical current. Okay, so that's all just R. Is directly proportional to, well, there's our wording from earlier. What do I have? Length is going to be L. I usually do lowercase for length, like length times width. And inversely proportional to, there's more wording. And then what's this one?
Cross-sectional area.
A sound good? Okay. So now we have our variables. We have R standing for all that stuff. We have L standing for that guy. We have A standing for that guy. And we have our wording. Has anybody figured out the model? Or what's going on? R does equal K. Hold on, I don't have a T in here. All I have is R, L, and A. Yeah. K times L, how do we know that? Directly proportional means k times whoever's there, right? But inversely proportional, here's the idea. K can be times L, there's that direct variation over A, while also being inversely related to another quantity by using division. So R, since K is being multiplied by L, R is directly proportional to L, but R is also, since there's division, R is also inversely related to A. We don't need two different K's. One constant can carry it all. We could have made it like a K1 and a K2 and made it just a new K. But this is sufficient. Usually if we have like one constant, like a 2 times and a 3 times, we combine it to make it 6 times. That's kind of why I just leave 1K. 2 constants multiplied would just be a new big constant. I think I said 4. Is there one more? Uno más. Joint variation. Think in like legal terminology, if something is jointly occurring, it's usually involving both the parties, if that kind of makes sense. You can think like joints in your body, they're connecting two pieces, you can think of it that way, not connecting. Mom's not a biology teacher. But joints are usually in between two different, whether bones or two different, it is somehow bringing together. So varies jointly. Okay, somehow there's like a relationship between multiple parties. Whatever's on this side is still the green. Now you guys notice there's more variables now because we have, oh, I moved my boards that day. So that's what I should do. It's not a y anymore, it's a z because I have x and y on the other side, but it doesn't matter. I still have the green box. I still have the dependent quantity. Because now he might be dependent on more than one variable. Or more than one variable. On more than one variable. So do you guys see how it's still direct variation, but it's direct variation and it's z is related to x and y, so we just call it a joint variation since there are two different quantities. It's dependent on both of those. So the next thing is you guys read down below. Hopefully you can pick out those quantities that it's talking about pretty quickly. And maybe you can even pick out the varies jointly wording. The dilemma is don't miss anything. Don't leave anything out. Else we get in trouble the same way the court reporter would and the secretary would. So, kinetic energy E of an object varies jointly with the object's mass and the square of the object's velocity. How can we take that statement and model it quickly? E equals
KMV, the V squared.
Because we need both of the quantities and, but also the, don't miss it, square of V. You guys thought this section was going to be crazy, right? It might be, but the wording is very specific. And the clues help us get the model. Now pause. Well, that's a good question. Once we get the model, we might have to work for the equation. And once we have the equation, they might have us use it. So let's go ahead and see if there's an example of that. Oh, calm down. Models are made for using. Equations are, no, you're supposed to sit there and the equation is supposed to be like, there I am. You don't want to use them. They're artifacts. Okay, no, equations are meant to be used. So let's go ahead and use, this is a very basic, look, there's like barely any words to it. Okay? But there are some numbers to plug in. That's okay. What do we plug the 4 and the 8 pi into? I don't know. You have to make the equation. Using what? The wording. Y varies directly to x. So you have to make the equation before you can plug into it. Wait. No big deal. We've done this, right? Y varies directly to x. What is that model that we're supposed to be using? Okay. So we start here, y equals k times x. That's accomplishing this first task. We've translated it. But what do we still have to do?
Solve.
How do we do that?
Plug it in.
Easy cheesy. Plug in the 8 pi, substitution. We don't know k, that's kind of the point. We plug in 4, and we say, okay, fine. If this is true, if y is 8 pi when k is 4, and I know it has this relationship, these two quantities, solve for k, what do we get? Now, is that solving the model? No. But it's finding the missing piece to solve the model. The model is the equation. They ask us for the model, we just need to get the equation with the k plugged in. Dun, 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 dun. Right?
We just put like
The word. What you saying that?
We just put the number before the K.
Oh, you can. I just strictly plugged it in the way it was written, like I'm kind of used to. But it could be 4k and then you divide by 4. That works too. Do we have the model? Yes. Are they asking for us to do anything else? No. Sweet. That one's done.
There's another one.
I have to show you examples, or else you're going to freak out when you see something different. Nah. This one says, we're giving you the information differently, but we're telling you these x's and y's fit one of these models. These x's and y's fit one of these models. So we can do a couple different things. If you guys like patterns, you could ask yourself the idea of direct and inverse, and I kind of mentioned it earlier. Directly related means, if you have two different quantities, think like algebra, you have scales, right? You guys have ever heard the balance the equation and to keep the equations balanced. Okay. If y goes up in a direct variation, x goes up too. Direct variation, if y goes up, x goes up. They're directly related. What one does, the other does. Inversely related, the idea behind it, as one goes up, the other goes down. Which was why the demand and price thing was inverse. Demand goes down as the price goes up. Fewer people are willing to buy it. So inversely related, as one goes up, the other goes down. If you get that idea, you can look at the x's and say, hey, the x's are going, and the y's,
They're going down. Up.
they're going up as well. So it must be this one. Don't touch. So as x goes up, y goes up, it must be directly related. Now, if that didn't work for you, the other way that you can think about it is the following. You could say, all right, fine. If this one works in that equation, I should be able to plug in when y is 2, x is 5, right? I should be able to solve for k, so it would be 2/5. Then I should be able to take that, plug it into my model, and it should work for all the other points, right? So I should be able to do the same thing with 4 equaling k times 10, and what should my k still be? Yeah, so if it is 2/5, I've got it, and I'm right. Is it 2/5, 4/10? Yeah. So you could have just plugged in and tested and seen, like, hey, is it going to work every time? The answer is yes. If I plugged into that one, I'm going to get all sorts of different k's. It's not working. I could solve for k's, but they're all going to be different for every single point. That's not going to work. I need one that stays constant or consistent. So wait a minute. Am I supposed to box that, or am I supposed to box this?
The first one.
First one is the right type of model. But if they said determine and solve, the final answer, I determined and I solved. Dun, dun, dun. Dun, dun. That make sense? I know, we're so awake today. Jordan's a little unruly, but it's okay. All right. Pause. There are more words to this one, but question, has anything really changed from the two that we've done?
No.
Because you can pause, you can keep your pencils down, I don't mind on this one. I feel like it's just like the other two, because what did it tell us from the very get-go?
Simple interest.
Directly proportional.
Do you remember what variable to use? It's principal. In principle, it's the beginning amount of an account. What equation are you guys going to tell me to make? Am I done?
No.
Because what do I still need to do?
Plug it in and solve it.
So I'm going to plug in and solve for k, and then I'm going to make the equation out of K.
Yeah.
So I'm gonna plug in the investment. You're putting in 6,500. It's being multiplied by some sort of interest rate. You guys know about how rates work. It makes sense it's multiplied. And you're getting out an interest of 211.25. That's some sort of return. And it's over like 60 years. Anyway, so the way econ's going these days. You would have to go ahead and solve for K. Come on, someone keeps their calculator close. Find that for me. You plug and chug, you find the K, and once you find the K, all we have to do is
0.0325.
well, put it in. What do you got?
0.0325.
Someone back them up, 0.0325.
Yeah, that's right.
Which would be the same as what percentage? Through the decimal, 2 places to the right. What percentage?
32.
3.25%. If it was 32, it would be a great investment, but very unrealistic these days. Okay. Well, very unrealistic. 32. 3.25 is still. Whoa! No! Seriously?
2 seconds. 2 seconds. I'm not done.
Oh, on the notes. Yeah. Kiddos, go down, grab out your homework files. Let me get you the homework assignment, and let me get you into the homework itself. If you have your book, proceed. If not, I'll pull it up so that you get started. And I have 1, 2, 3, 4, 5, 6, 7. The first 7 people you up there can have the book on the shelf for right now. Ready? Do we go right now? If you have your locker in the hallway, you can go grab it out of the hallway. But real quick. Mine's at home.
You have to pay $1 now.
Yeah.
I did 1.10 last night. I looked at the calendar wrong and I just finished it off.
So you're totally good?
Yeah.
I'll have you write down the test for you.
Most of them I was confused. I think I can get it in class.
Yeah, no, I'm glad that, hey, you got pretty far. Good job. Yeah. Don't get lost, make it quick. Go. Oh no, I'm studying heritage students on South Campus. Alright, cool kids, here we go. I'm gonna make it big. Go ahead and write down this homework assignment. Does anybody not have their book and need me to open? If anybody did happen to do 110 last night, I had a couple kids that said they did a lot of it. Write down their review, let me go. Don't worry, I can show you lots of extra problems to practice with over the weekend. This one? I'll pull it up and look at it. That's part of the reason I want to start in homework, because there are a couple places you get stuck on this one, and so I can help in those hard problems. Alright, kiddos, grab a seat, open up your spiral. If you still need a book, I still have 5 of them up here. Some of you went outside and didn't get a book, so come grab one. Yeah.
Do you have a pencil sharpener?
I have the little one that you can hand crank, or I have one at the front of them. That's electric. You can use the blue electric one. Yeah. Or not, it's not a hand crank, sorry. It's a... Alright, kiddos, get down to your assignment. I'm going to pull up the homework and actually try to help you guys on some of the trickier ones as we have time. Sorry, it wasn't hand crank, it was that orange twisty thing above. Just in case you ever need it back then. Alright, you guys should be able to start homework, but I want you guys, like, for instance, one person's already told me number 18 is hard. Sweet. I'll let you guys hopefully get to number 18 and let's talk about it. Let's figure it out together. Sound good? So get into it. I think 18 is a hard one. So I'm letting a few people get into their homework. Kiri, do you need a book? I have one. Here you go. Come grab it. We're doing homework. Where's your spiral? Okay, start doing homework. Assignment's right there. I know you're tired, but I'm trying to make tonight be better. Trying to make tonight be better. Yes. You're gonna have to remember that whole list page from the Precalc graphing calculator handbook to the beginning of homework. But the nice thing is I'm close. If you don't remember, how do we put a table into our you want to hit stat, right?
Oh, snap.
So to do your list, you want to hit stat and then edit.
Oh.
You want to turn on your stat file. Zoom stat is a great one to use to see it a little bit clearer, a little bit better. Did I give you one? Number 8. Don't be scared of number 18. Homework starts out kind of rough, but wait. It's like the handbook. It's okay. Get the table in first. But pause. Before you get too far in putting in your table, what did they say to make 1995 in letter A? So if 1995 is 5, then 406 is your list 2 or your Y. What would you make 1996? 6. Because 1995 is 5 years away from 1990. 1996 is 6, so make 1996 6. 1997, make it 7. It's just trying to make it faster for you to input the data and make it fit in your graph a little bit nicer. So make this one 5, 406, 6, 436, 7, 499. And then keep going. You want all that data in.
2,000 be 0 or 10?
Good question. 2,000 will be 10.
Okay.
Will be 10.
And then 11 or 12.
Right.
Okay.
It just keeps on going.
Yeah.
And I think, guys, there's not any jumps, right? You can pretty much count by ones, I think.
Yes, ma'am.
All by ones? Yeah. Alright, if you don't have a graphing calculator, you can ask someone around you and be like, hey, you put in half the table, I'll put in half the table, and we'll work together on it.
I'm a one-man show. Six.
Yes, I appreciate that.
2001 space.
2001 was the year of the devil. That's the year before I was born. That was the year I was
That's
born.
that's great.
awesome.
You know, that's good to know. But I don't know that.
Oh, man.
Hey, Delight. Hey, not much. How are you? I'm awesome, bro. It's Thursday.
Oh,
It's Friday Junior, bro.
Friday Eve.
Friday Junior, bro.
What?
What up, Joel? What up, Michael? How's your blog going, bro? How's it